Today we're going to be finding all roots of polynomials. Our objective is that we will be able to find all the roots of a polynomial. So last class we learned how to find all the rational roots of a polynomial using synthetic division and factoring. What if we can't factor as our last step for the remaining zeros? We can find the remaining zeros using complete the square, or the quadratic formula. So here we're given a polynomial and we're going to find all the zeros. The first thing we want to do is look at the graph. Okay. So zoom out a little bit. It's a really tall one. All right, so we see that it has one real zero at -3. Because it has an x cubed, we know it has 3 zeros total, so that must mean our other two are complex. But this one at -3 is going to help us out. That root of -3 gives us the number to use for our synthetic division. So -3, 1, -5, -7, and 51. So let's do our synthetic division. Bring down the 1, multiply, add, multiply, add, multiply, add. We get a remainder of 0. Since we know from the graph that -3 is a 0, if we had gotten anything other than 0 as our remainder, we should have gone back and checked our synthetic division. So now I'm going to write my new polynomial. I'd have x squared minus 8x plus 17 equals 0. So I'm going to do this one using the complete the square option. If you want to try using quadratic formula, you can. The nice thing about this is there's a, b, and c. So if we're going to complete the square, we'd first have to move 17 to the other side. I'm going to leave a blank because I know I'm going to add something to both sides. Then to complete the square, I would do -8 over 2 squared. That would give me -4 squared, which is 16. Add that to both sides. I'm going to factor the left-hand side, x minus 4 squared. Simplify on the right-hand side would give me -1. Then I'll square root both sides. We get x minus 1 equals plus or minus I. And then finally, when I add 4 to both sides, I get x equals 4 plus or minus I. Now, those two are not our only solutions. We also have our -3, that was our real solution. So -3 and then 4 plus or minus I. Those are my 3 solutions. Let's try another one. So again, I'm going to start by putting it into Desmos to look at the graph. All right, so here I see that I have 3 real roots because it crosses 3 times. That one's a decimal, that one's a whole number, that one's another decimal. The decimal ones aren't going to help us out. The whole number is what we want. So we're going to use 2. So 2 goes outside the synthetic division. And I have 1, -6, +9, -2 for my coefficients. Bring down the 1, multiply, add, multiply, or sorry, multiply, add, multiply, add. Again, we already know that 2 is a 0, so if we had gotten anything other than 0 as our remainder, would have been a hint that something went wrong in our synthetic division. So this is x squared minus 4x plus 1 equals 0. So this time I'm going to show you guys it with quadratic formula. Again, you can use either quadratic formula or complete the square. It does not matter. So let's start with our discriminant. B squared minus 4ac. And that gives me 12. So I know x equals -b plus or minus square root of our discriminant over 2 times a. Let's simplify my radical. So I get x equals x equals 4 plus or minus 2 square roots of 3 over 2. And then everything's divisible by 2, so this simplifies to 2 plus or minus the square root of 3. So my final answer would be that x equals 2 or 2 plus or minus the square root of 3. Remember, if you start with whatever the degree of your polynomial is, which in this case, and in both of our examples was 3, that means I have 3 solutions. 2 is one of my solutions, 2 plus the square root of 3 is the second one, 2 minus the square root of 3 is the third one. That's all for today. Fill in your summary and we'll see you in class.